We're going to talk about analyzing meaningful intervals of change, which is very important for variable creation as well as running regression models. Typically, when you're running regression models, you'll either be using linear regression, such as a regress command, or a logistic regression, where you'll be using the logistic command. And you'll be looking at the relationship of an outcome variable to your predictor while accounting for covariates, if you so choose. When you look at the predictor variable, what you're actually looking at is what is the impact of a 1 unit difference in the predictor on the outcome, either with regards to linear change or with regards to the odds of a dichotomous outcome. So you have to ask yourself whether a 1 unit change in the predictor is really something that you want to analyze. And this may differ depending on what your predictor is. So let's discuss some predictors that we actually have in our data set that we've been working on, looking at reading and glaucoma and dry eye. And some of the predictors are visual acuity in logmar units, contrast sensitivity in log units, visual field expressed as the mean deviation in the better eye. This includes some other ones such as age, what percentage of the comprehension questions they got right as a proportion, and just for illustrative purposes we'll use gender as well. We have to think about first what is the range of values that we see in our data set. So and that helps us understand whether a 1 unit change is really meaningful. So for logmar, it goes from about -0.2 to 0.4. Log CS goes from roughly 1 to 2. Mean deviation goes from -30 to 3. Age goes from 50 to 90. Comprehension goes from 20% to 100%, although it's a proportion. And male is either 0 or 1. Then we have to think about, well, when you're talking about a 1 unit change, over what percentage of the range is going to be spanned by 1 unit. So percentage of range covered by 1 unit. And you can see that it can differ drastically across these different predictor variables. So here it's going to actually be greater than 100%. Here it'll be precisely 100%. Here you're talking about 3%, 2.5%, again greater than 100%, and again 100%. Well, what is a better unit of change to assess? And how are we going to decide that, rather than simply 1 unit of that raw predictor value? So how are we going to decide that? Well, let's think about it. First of all, we're going to want to look at something which has some clinical meaning. We'll want to choose a number which makes sense, so we probably don't want to look at a 2.3 unit change. We'll probably want to use something which is somewhat a round number. We'll want to look at kind of, the percentage of the range covered. And typically I like to have a unit change which represents about 10 to 20% of the range of values in the data set. And then finally we're going to want to decide whether we want to look at positive change or negative change. So let's think about logmar first. It turns out that a 0.1 difference in logmar represents a 1-line change, which is also about 15–16% of the range of values observed. With log CS, we can also look at a 0.1 change. For mean deviation, we want to look at more than a 1 unit change, so we can look at something like a 5 decibel change. For age, we could look at about 10 to 20%, which maybe be about 5 years, but I think we all better understand what it means to be a decade older, and so 10 years might be better. Comprehension, we understand 10% or a proportion of 0.1 to represent the difference between an A and a B or a B and a C, and so that might be good. And for male, there's really only one option here anyway. We're also going to want to think about whether we want to look at positive change or negative change. I tend to want to look at things which predict worse performance, and so we're going to want to think about what would be most likely to predict worse performance over here. We're going to want worse visual acuity, which actually means higher logmar. We're going to want to have lower contrast sensitivity, so a negative value. a lower mean deviation, which again is going to be negative. We're going to want to have higher age, worse comprehension. And so then the final question is, well, how do we actually transform these data how do we transform the original predictor value so we get a revised predictor which represents this unit of change? We'll illustrate this in detail, but here we're going to actually want to multiply by 10. If we want to look at a 0.1 unit change, here we'll want to multiply by negative 10, so it's 0.1 but negative. When we have a number that we want to look at a larger number, we actually want to divide. So here we'll divide by negative 5. Here we'll divide by 10. And again, this will be the same as above, where we'll multiply by negative 10. And there's nothing to do over here. Well, how do I come up with these numbers? Well, you can simply take them from here if you want to look at it, but you can also think your way through this. So let's think through a couple different examples. So let's first consider logmar, which, as we remember, goes in our data set from negative 0.25 through 0 to then about 0.4. And if we wanted to look at a 1 unit interval of worsening starting at the normal value, you would start here and you go past the edge of the range of where values are seen all the way to around here, which is something which is obviously not very physiologic. Let's think instead now if we looked at logmar 0.1, which remember is 10 times logmar. So if we multiply these values by 10, we're going to get negative 2.5, 0, and 4. And so now a 1 unit worsening starting at the normal value is going to again be in the same direction but represent a reasonable portion of the range of values observed in the data set. Let's now consider a different example. Let's consider a mean deviation in the better eye. And so values here range from negative 30 through 0 to about 3. So if we wanted to look at a 1 unit worsening starting at the normal value, which is 0, it would start at, if we want to look at a 1 unit change starting at 0, it would go from 0 to about 1 and it'd go right about over there. So it's actually not worsening, it's actually improvement because that's a plus 1 unit change. Now let's think about a mean deviation of the better eye divided by negative 5. And the data set, this will be called MD better eye 5 worse. Now when you divide it by negative 5, this will become 6, this will become 0, and this will become 0.6. And now a 1 unit change will start here and go about here. Now you're looking again that it's going in the right direction, in other words worsening, and it's representing a reasonable portion of the data set. Let's see how this actually works. So let's go to Stata, and I have a data set loaded up over here. IREST1 is the reading speed. Slowed means whether or not the readings slow down over time. That's a yes-no variable, and these are some of the predictors that we talked about earlier. So if we look at how much people's reading changed with a 1 unit change in logmar acuity, we see that there's a massive change. So they read 71 words per minute slower with each 1 unit change, because this represents the entire dynamic range of visual acuity seen in the entire data set. So better instead to create a value of logmar 0.1, which is equal to 10 times logmar. And when we do that same regression now, we see that the unit of change is 1/10 as much. So instead, for each 0.1 unit change in logmar, they read 10 units worse. Well, that seems pretty obvious, and in fact, you probably don't even need to make this new variable, because you could just divide the coefficient as well as the 95% confidence intervals values by 10. Well, that's easy when you're dividing by 10, but on the other hand, if you wanted to divide by 5, it's not quite so easy, and you're going to have to do a lot of calculations. So let's do the same thing here, where we regress this now against better eye. So we see now for each unit change in the mean deviation, you actually have an improvement in reading speed, because a 1 unit change in mean deviation means that you're actually seeing better. And now you also see that the change is very, very small. But we want to look at a more reasonable increment of change and also look at it in the direction of worsening. And so we're going to want to generate a new variable which represents 5 units of worsening in the better I mean deviation. And that's going to be mean deviation better I divided by -5. So now we're doing divided by, because we're looking at 5 units of change as opposed to a unit of change which is less than 1. And now we're going in the opposite direction. You see some missing values because there's some patients with dry eye who didn't have any visual fields. And now when we look at I-rest mean deviation regression and look at 5 worse, you'll see that all these values are multiplied by -5, these are the values that are derived over here. You can see that they're flipped around over here, so this becomes multiplied by -5 and this becomes multiplied by -5. So they're in the opposite direction as well. So you could have gotten that just by multiplying everything, although you have to do a lot of multiplication. On the other hand, the other advantage of transforming the variable is if you end up doing logistic regression. So now instead of regressing the relationship between I-rest and logmar, let's go ahead and look at a logistic regression where slowed reading is the outcome and logmar is the predictor. And you can see that the odds ratio is huge, 20, massive, although not that statistically significant because you're actually looking at a unit of change which spans the entire range of logmar acuities. But instead, if we look at logmar 0.1, which is now a 1-line change, you see only a 35% increase in the odds ratio, although the same p-value. And there's no way to linearly transform this. You'd actually have to do exponents and other things, and it's really not worth your time. So it's going to be a lot easier simply to transform the variable rather than simply transforming the odds ratios and the confidence intervals. Thank you.